Mm-hmm.
Hold on a moment. Let me get this set up.
No problem.
Okay. And you've already started on some of these, or just gotten started?
Yeah, I got started on a few of these.
Okay. Looks like you did that fine. In other words, starting with y equals mx plus b.
Mm-hmm.
Is that what you did?
Yep.
And
yeah.
it,
What?
and it
Yeah.
started at 1, which was b,
Mm-hmm.
because of that. And then
Yeah.
figured out the slope had to be down 1 over 2 in a negative direction.
Mm-hmm.
So, okay, that's good.
Cool.
Writing equations in point slope. Okay, there's point slope. Notice that point slope, if you isolated m, you would have y's over the x's.
Okay.
In other words, that's kind of the definition of slope.
Mm-hmm.
The difference of the y's divided by the difference of the x's. Rise over run.
Okay, yeah.
Okay, and here they've given you 1 point and a slope, and you just substitute directly in for that.
Okay.
And you simplify, and you end up with this.
Okay.
It's really not much simplification. It isn't solving for y.
Yeah.
Okay, that's the final answer right there.
Cool.
Okay, write an equation in point slope. Okay, y minus 7 equals minus 1. Okay, you get that.
Cool.
Okay, so here's a task where they want it in slope-intercept format. So we want it to end up all y on one side, but they're telling us that we can use point slope to get there first. In other words, we can start it with point slope if we want, and then go to y-intercept.
Okay.
Let's see. Right offhand, number 3 doesn't look correct to me. Maybe I just haven't looked at it long enough here. Hold on a second. Let me open the page. And all right. So you got the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1.
Mm-hmm.
So that's a slope of 8 over minus 8. Hold on.
Okay.
I'm not used to seeing it in. Okay, so one of our points is 5 comma 10.
Mm-hmm.
And the other point is 2 comma minus 3.
Mm-hmm.
So that gives us 13 over 3 for a slope.
Okay.
Now, here, let's label this. This is x1. This is y1. This is x2 and y2. Now, typically slope is defined like this. Right?
Yeah.
Well, you can go the other direction if it makes the math a little easier. In other words, we don't have to do minus 3 minus 10 all divided by 2 minus 5. It's a lot of negative numbers.
Yeah.
In this particular problem, it's actually easier to do 10 minus a minus 3, in other words, y1 minus y2, all over 5 minus 2, which is beneficial because we don't have as many negative numbers in our answers.
Yeah.
That's 13 over 3.
Okay.
So that's the slope.
Okay, cool.
Let me just see what you did here to get this. What does that say? X sub 2?
Yeah, sorry.
That's y sub 2?
Yeah, that's y sub 2. Yeah.
Well, hold on 1 minute. Maybe I did this wrong.
Okay.
You know what? I did it wrong. When I labeled everything here, that's because I'm not used to seeing it like that.
Yeah, it can be kind of confusing.
Well, I'm just I'm not sure I've ever seen it given 2 points like that. Yeah, that's the x value. In other words, when x is 10, f of x is 5. So that means when x is 10, f of x is 5. And when x is 2, f of x is minus 3. Now let's try it and see what we get.
Okay.
Well, I'm still going to go this way to this way, but now I get 8 in the difference of the y's and 8 in the difference of the x's. So that gives me a slope of 1.
1. Okay, so it'd be y equals 1x plus 5.
Well, we don't know what b is yet. We know this much.
Yeah.
Okay? Now, there's 2 ways to go here. Let's talk about both of them. You want to be really familiar with multiple ways to do a problem.
Okay.
Okay? And one way is to plug in one of these points in for y and x and solve for b.
Okay.
Personally, I think that's the easiest way to go. And notice I have solved for slope. Slope equals 1. But you could go direct to point slope. Let's do it both ways. Plug in, pick a point, plug it in, let's solve for b, and then let's also do it point slope method.
Okay.
You can pick either point, whichever is going to make the math easier.
So we could probably do 5.
Okay?
Okay.
So 5 equals 10 plus b. What does b equal?
B is equal to 5. No.
It's 5 minus 10.
Oh, my bad. Minus 5.
Okay? So that equation becomes what? Y
Equals 1x minus 5.
Okay, so that's the answer. That wasn't too hard to come up with that way. You just have to remember you have to solve for b. Now let's do it point slope. Pick any, in other words, point slope is this, and notice that one of the y's has a subscript, the other does not. Same with the x's. Well, you're only going to pick one point, and you're going to plug it in for that and that. We know our slope is 1, so what does that give us?
So our slope is 1, so...
What do I need to write here?
So y minus y1, so...
What's y1?
y1, oh, 5. So y minus 5 is equal to... Where is it?
1.
Yeah, 1, and then... Where's x1? So 10.
X minus 10.
Or x minus 10, yeah.
In other words, we're only plugging in for that point right there.
Okay.
Okay?
Okay.
What's left is an equation in y and x. Well, y minus 5 equals x minus 10.
Okay.
That would be the answer if they wanted it in, if they didn't mind point slope format. But notice it's the same equation. In other words, if I take this and add 5 to both sides, I get y equal x minus 5.
Okay.
So it's the same equation. It's just we chose to do it in 2 different ways. Now, this way was 1 step, 2 steps.
Yeah.
This way was 1 step, 2 steps if we wanted in slope-intercept format, but then 3 steps if we wanted in slope, 2 steps if we wanted in point-slope format, 3 steps if we wanted in slope-intercept. Since they want this in slope-intercept, probably better to do this way. It's only 2 steps.
Yeah.
Okay? So, let's choose this technique for the rest of the problems.
Okay. Sounds good.
Now, let's see. Here you have x2 and y2 and x1 and y1. Okay. Doesn't really matter which is which. You could have used x1 and y1 here.
Okay.
They're just 2 points.
Yeah.
So we're going to do this how?
So slope-intercept form.
Okay.
So we could do
y
equals
equal mx plus b.
Okay.
So let's solve for m.
Okay. Alright, so the slope. X2, so we could do 5. So y is equal to -2. So -2x.
Hold on. We're doing number 4. I got a y sub 1 is -4 and a y sub 2 is -4. So what's the difference between those?
That'd be 0.
Okay. We don't even need to do the denominator.
No.
We know our slope is 0.
Okay.
So that means y equals 0x plus b.
Okay.
Now pick a point, substitute it in for y and x, and you got b.
Okay, so 0x. Let's do 5. No, my bad. Let's do, -4, because it's y.
Okay, so we got -4 equals 0 times 5 plus b. So what's b equal to?
-4 is equal to 0 plus b. So
b,
it'd just be 0.
no, it's, in other words, that term goes away.
So
We got b equal -4.
So it'd be -4.
Right, so the answer then is...
y equals 0x minus 4.
You don't write the 0x because 0 multiplied by anything is
0.
So this is what we're used to seeing as the equation of a horizontal line.
Yeah.
Well, that is a horizontal line, notice. In other words, both y values were the same, -4. So no matter where, excuse me, let me draw that a little differently. No matter where you're at on the x-axis, y goes through -4 like that.
Okay.
Whether you were at 3 or whether you were at 5, y was -4, and since we're talking linear equations, it's got to be horizontal the whole way.
Okay.
Okay, so that's just y equal -4.
Okay.
Now, it can be a little tough to do that subtraction if you're not comfortable with negative numbers. In other words, when you did y sub 2 minus y sub 1, you apparently did this and got -2. Well, if we apply the principles of algebra, then these two minuses turn into a plus, and I get 0. But more importantly, Dylan, when you subtract two numbers that are the same, you always get 0.
Yeah.
It doesn't matter whether they're positive or negative. If I got 8 minus 8, that's 0. If I got -100 minus a -100, that's got to be 0.
Okay.
Because that number is the same as that number, and we're subtracting them.
Okay.
Okay? So whenever you see the same numbers, know that it's real easy to subtract them. It's always 0.
Yeah. Okay. Cool.
All right, let's do 5.
Okay.
Okay, so we're going to use slope-intercept. So what's the slope?
M. So y of 2 minus y of 1 over x of 2 minus x of 1.
Okay. What is y of 2 minus y of 1?
Let's see. 5. So.
Okay, are we going to go that way?
Yeah, we could do that.
Okay, that means we got to go the same way on the x's.
Okay.
You can't reverse it just to make it positive. You're going to end up with the wrong sign on the slope if you do that.
Okay.
So what's going to be in the denominator?
-3.
Okay. So our slope is -5/3.
Okay.
Okay, and you're clear that this is exactly the same as this,
Yeah.
which is exactly the same as that.
Okay, yeah.
Okay?
Mhm.
So our slope's 5/3. Now what?
And then we could substitute a y value, so we could substitute 6. I mean 8, my bad.
Okay.
So 8 is equal to negative 5 over 3 plus b.
Okay, you got to substitute for x also.
Oh,
In other words, in the last problem, that slope was 0, so it didn't matter what x was.
yeah.
But in this case, that slope is not 0. It's minus 5/3, so we need the x value. What's the x value that goes with 8?
Because, oh, 3. Oh, so 6. Okay.
Okay, now let's solve this equation.
Okay. So it'd be negative 10. So, plus b, yeah. Then you just add 10 to both sides. And then b is equal to...
Yeah, rather than telling me what you're going to do, just read the next line. And that way I'll know whether you did the right thing or not.
Okay, so b is equal to negative 2.
Okay? We're going to add 10 to both sides.
Oh, my bad. 18.
Okay.
Yeah. Okay.
I want to turn you on to a site I found
Okay.
that I've been looking for a long time,
Okay.
because I have a lot of students that really, really would benefit from spending a few minutes a day on this site. It's the only app or program I've come across that allows you to play with negative numbers.
Oh, that's
And
cool.
that's where everybody has problems.
Mhm.
You don't need to be able to do two-digit numbers, but you
Okay.
need to test yourself on addition, subtraction, multiplication, and division using both positive and negative numbers. So
Okay.
let's just spend a few minutes on this. I know this would
Yeah, sure.
I know this would be tremendously helpful to you if you
Yeah.
get good, if you would get better at this. It's not like your skills are horrible, but I do notice that you make a number of mistakes, and it's going to be hard to advance very far in math. Keep making those mistakes, because you can understand the algebra of it, and if you make arithmetic mistakes, you're going to be screwed. So let's get good at this without a calculator. If you've got a calculator in front of you, put it aside. Let's just practice on these.
Okay. Yeah, I don't have
the answer, and I'll put it up.
Okay, negative 2.
Do it as fast as you can.
Negative 2. Negative 3. Negative 2. 11. Negative 1.
Okay, how come you're so good on this?
2.
I'm serious. You're so good here, and yet you make these kind of mistakes
Yeah.
repeatedly when we're solving algebraic equations.
Yeah.
So
Negative 2.
maybe you don't need this as much as I thought. This one.
Negative 5.
Okay. Pretty good.
And 10.
All right. Huh. Interesting. So.
Negative 6.
Yeah, very interesting.
Yeah.
You know what that tells me, Dylan?
Yeah.
It tells me that as soon as you focus, you're good.
Yeah.
And I'm guessing what happens is that when you're confronted with equations like this, I don't know if you lose focus or what happens. How did you get?
Yeah,
How did you get
I don't.
-2 there? It must have been that you just combined 8 and minus 10.
Yeah, I just get kind of confused on that, like in equations. Like I can do it like just like
Yeah, you know
yeah.
your arithmetic. Well, that's a huge plus. That isolates, tells me what the problem is not.
Mhm.
Most schools force you to do this laboriously long
Mhm.
by doing this.
Yeah.
Okay? Then
Yeah.
everybody sees that cancels. You get B over there. You get 18 over there.
Okay.
If you did that, you would not have made that mistake you made.
Yeah.
Now, I've always kind of skipped that step because I didn't like it.
Mhm.
The way I approach algebra problems is not so much doing that. I'll tell you how I do it.
Okay.
If I want to move something that's being added to something to the other side of the equation, I just
Mhm.
move it over there and change its sign. That's what I do. I don't even think about it as adding 10. What I think
Mhm.
about it is I'm going to move that negative 10 to the other side, therefore it becomes a positive 10.
Okay.
If it was a positive 10 in the first place, and I'm going to move it to the other side, then it's got to become a negative 10.
Yeah.
Okay? And perhaps that would help you, I don't know.
Mhm.
Probably more important is you need to slow down a little bit and focus and pay attention to detail.
Okay.
And try not to get the whole answer all at once as quickly as you can, perhaps. Okay, so we're done with this page, right?
Yeah.
All right, let's go to the second page. You know,
Okay.
I'm not even going to paste this in there because I thought this was the problem, but you just proved me wrong.
Okay.
This is, however, a terrific little app. It's A+ Math. And
Okay, cool.
I really do think people that do struggle with the arithmetic, that's a
Mhm.
tremendous place to go.
Mhm.
All right, let's open up the second document.
Okay.
Somebody was holding the camera particularly steady here.
Yeah.
That is a good, sharp, crisp image.
Really is.
All right, let's see.
I found out that the Samsung Galaxy S5, the phone my dad has 30 megapixels.
Oh my goodness, is that what took
Yeah.
this picture?
Mhm.
Yeah.
Yep.
Wow, he probably
Yeah.
doesn't even have to hold it still. I got
Yeah,
5
seriously.
megapixels, and I can come close to this quality, but I have to hold it so still or have it on a tripod.
Yeah, me too. My camera's pretty bad
Yeah.
on my phone.
All
Yeah.
right, let's talk about what they're talking here. Parallel and perpendicular lines. What's parallel mean?
Parallels mean where they're, I guess you could say like parallel to each other, like they don't
What's
intersect.
it mean about slope?
Slope goes up at a constant rate.
Hold on. Let me draw 2 parallel lines, and you tell me what it means about slope.
Okay.
There's one parallel line. There's another parallel line.
The
So there is
slope
a
is
parallel
equal.
line to the first one.
The first, they both go up at a constant rate of
So the
change.
slope is the same.
Yeah.
If that's M1, that's also M1. So that's
Mhm.
the first thing to learn, is that the
Okay.
slopes are the same if 2 lines are parallel.
Okay.
Okay? If 2
Mhm.
lines are perpendicular,
Means they intersect.
means that
Oh.
their slopes multiply to the number 1. But the
Okay.
easier way of remembering it is that the slope of 1 is the negative reciprocal of the slope of the other. So
Okay.
M1 to its perpendicular would always be that. In other
Okay.
words, if this slope is 2, what's this slope?
-2.
Negative reciprocal. Negative 1
So,
half. You have to do 2 things to convert. You have to flip it, and you have to change its sign.
so 2 over, -2 over 1.
No, negative 1 over 2.
Or -1 over 2.
Notice that these two multiply always to negative 1. I'm sorry, I made a mistake first time. They always multiply to negative 1, although that's not something terribly useful to remember.
Okay.
I don't know why I said it. When I read it the other day, I said, you know, I didn't know that, but it's not helpful. What's helpful is to know negative reciprocal.
Okay.
So, let me give you some negative reciprocal problems. If the slope of one line is that, what's the slope of its perpendicular, a line perpendicular to it?
Would it be negative 1 over 3?
Okay. If the slope of a line is negative 1/5, what is the slope perpendicular to that line?
5.
Okay.
Cool.
That's all you need for this section.
Okay.
All right, let me read your answers. Maybe you got it. So A passes through 0, 4, 4, 3. B passes through those. C passes through that. Or parallel or perpendicular. Okay. Well, what do we have to do before we can answer this?
Probably put it into an equation.
Nah. Just need to figure out slopes. In other words,
just graph it.
No.
Everything
can be answered. In other words, we just showed that parallel and perpendicular are related by either they're the same slope or they're the negative reciprocal of the slope.
Okay.
So what we have to do is figure out the slopes of each of these lines. So what's the slope of line A?
Okay, so line A would be negative 1 over 4.
Good. Negative 1/4. What's the slope of line B?
1. Wait. So y2. Okay, sorry. So it'd be 1 over 4.
Make sure you go in the same direction. You can't choose to go 1 minus 0 and then divide it by 4 minus 0.
So 0 minus 1 is 1.
No.
I mean 0. God.
No.
Wait,
0 minus 1 is minus 1.
Minus 1, yeah.
Okay, here.
My bad, yeah.
That's what caused me to go to that other thing. But this is a particularly strange problem. So
Yeah,
if
my bad.
I'm subtracting, remember I'm going to turn all subtraction problems into addition problems. So I'm going to change the sign of that, and then I'm going to change the sign of what was being subtracted.
Add the opposite.
Yeah, so now the 0 goes away, and plus minus is minus.
Okay.
So 0 minus a number.
So it'd be negative 1/4 again.
Yeah.
Okay.
And what's the slope of C?
And C. 4. So C would be. So negative 4 over. Negative 2.
Okay, that's a perfectly good way to do it. I have no problem with that. Notice that if we went in the normal order, we'd have had positive numbers.
Yeah.
In other words, if we did 4 minus 0, we get 4, and if we did 4 minus 2, we get 2. So if you can avoid negative numbers, I would suggest you do.
Okay.
Otherwise, you're just introducing additional chances to make a mistake. Now, see, we have to divide that out. What do we get?
And then, so you just get positive 2.
Okay. And that's what we would have gotten if we'd have gone 4 minus 0 over 4 minus 2. We would have gotten 4 over 2, which is 2.
Okay.
It's a little cleaner. So
Okay.
always go in the direction where if you can go a certain direction and get nothing but positives, go in that direction. Now, in this, it didn't matter which way we went. We were going to have a negative in one, either the numerator or the denominator. Same way with this. It doesn't matter which way we went.
Yeah.
This one it does. Works easier if you go y sub 2 minus y sub 1 and divided by x sub 2 minus x sub 1. So now let's answer our questions. Which of the lines are parallel, perpendicular,
So A and B are parallel, and then A, B, and C would be, or just C would be perpendicular.
No. Perpendicular is the negative reciprocal. What's the negative reciprocal of that?
4.
Okay, that's not 2.
No.
Okay, negative reciprocal of that is 4. So that's not 2. So C is nothing.
Yeah.
C
So
is
just A
neither.
and B are parallel.
Yeah, A and B are parallel. That's the answer.
Okay.
But we couldn't determine it until we figured out slopes. That's why slopes are so important. And trust me, it gets more important. When you get into calculus, calculus is all about slope. The whole first semester of calculus is figuring out the slope of the tangent line. Slope is important because it represents rate of change.
Okay.
That's what calculus is all about, is rate of change. And that's what algebra slope is all about, rate of change.
Yeah.
All right, so number 7, we have to figure out the slope also. And, all right. What I really need is an app that throws algebraic equations at people.
Yeah.
But if you'll notice, algebraic equations are all about arithmetic. True?
Yeah.
There's nothing mysterious solving an algebraic equation. It's just making sure all your arithmetic is done properly.
Okay.
Let's go through this step by step with me. Read the next line. I don't care what you do, just read the next line.
Like line B, or...
Well, how would you solve this?
Oh, my bad. So all you do is add y to both sides.
Add 7y to both sides?
Yeah.
Okay, so that puts the 7y over there. Leaves
And then
2x over there.
Yeah, and then you would divide 2x by everything.
Divide 2x by everything.
So like divide 2x by 7 and 14.
Okay, so if we divide 2x by 7 and 14 by 7, and that was 7, that's allowable. We can do that. So now we have 2, that's not the best next step, but we'll back up for a second.
Yeah, I meant to say you divide 2x by 7 and 14.
Well, that's not what you do.
Okay.
Let's go back here a step.
Oh, you divide.
Because the pattern of solving an algebraic equation is the only thing you can get wrong. If you get all your arithmetic right, the only mistake you can make is not doing the method of solving an algebraic equation. I'm trying to isolate y. What should be my first step?
You divide 7.
That doesn't isolate y. That still leaves y plus 2 over there.
Could you subtract 7?
Not 7. 14.
I'll subtract 14.
Yeah, in other words, we're trying to isolate that, so let's get rid of everything that doesn't belong. Well, this 14 doesn't belong, and that 7 doesn't belong. The problem is if we divide by 7 first, it's harder. It's not wrong. It's just easier to think about solving algebra equations if you just start eliminating all the pieces that don't belong. Well, that doesn't belong. Let's move it to the other side. Now we have 7y. We're getting closer to isolation. It's not quite y yet, and the way to get rid of the 7 is to divide everything by 7.
Okay.
Okay, now you've got y equals 2/7 x. Separate that coefficient out on its own because that's slope.
Okay.
Minus 2.
Okay.
Now we know the slope. Okay? We didn't really need the full equation. We didn't really care about the minus 2 because the only thing we're going to compare is the slopes on these 3 lines. So actually the way you started to do this problem wasn't a bad way to do it. But it's bad algebraically. I hate to see you get in that habit of not solving these algebraic equations in the right sequences.
Okay.
Okay? So, the slope of line A,
2/7.
slope of line B,
7/2.
slope of line C, starting with 2x plus 7y equals minus 21.
Okay.
Solve that for y in the steps that I've told you.
Okay, so you would subtract 2 from both sides.
2 or 2x?
2x.
Yeah, in other words, we're trying to solve for that. We're trying to isolate that first and then y next.
Mm-hmm.
And that's being added to it right now. So let's subtract it. So
Okay.
we're going to move that 2x to the other side.
Mm-hmm.
And I don't even have to write it in the correct order. I can do it like this. That'd be the typical way you do it.
Okay.
Okay. Now what?
And then you would divide 7
Divide
by both sides.
Divide by 7.
7. Yeah, by 7. Yeah.
Every term.
Mm-hmm.
And notice again, we don't really care about that term. I don't even need to simplify it.
No.
What I've got here is y equals minus 21 over 7 minus 2/7 x. What is the slope of that line?
Negative 2/7 x.
Okay. No. It's negative 2/7.
Just negative 2/7.
Slopes don't have x in them.
Okay.
In other words, when you say slope, you're saying what is the slant of that line?
Mm-hmm.
2/7 is fairly flat. That's what I'm talking about. 2/7 right there. Negative 2/7 looks like this. But it's not 2/7 x.
Okay.
Okay, remember y equals mx plus b. M is the slope, and m is only the coefficient of the x term.
Okay. Cool.
So we had A was 2/7, B was 7/2, and C was negative 2/7. So what's the answer here? The question is, which, if any, of the lines are parallel or perpendicular?
Okay, so
Are there any parallel lines?
no.
Okay.
Yeah, they're all different. So would A and C be perpendicular?
No.
Well,
C is the negative of A, but it's not the negative reciprocal.
yeah,
It's
so none of them.
negative reciprocal.
Yeah. They're negative. So none of them would be.
What's the negative reciprocal of 7/2?
-7.
No.
I mean,
Negative reciprocal. Listen to those two words. Negative reciprocal. You got to first of all flip it, and then you got to change its sign.
so negative 2/7.
Huh.
Okay, so B and C are perpendicular.
B is perpendicular to C.
Okay.
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 Remember, negative reciprocal requires two actions, not one.
Okay.
All right. The classic algebra problem.
Yeah.
Here we have a line. And what they want is the equation of a different line. A line that passes through this point and is parallel to this line. So here's the line they want. That's where we're going to start.
Yeah.
What do we know about this new line?
It's in slope-intercept form.
What else do we know about it? It's parallel to the other
Yeah,
one.
it's parallel.
So what does that mean?
That means the slope will be the same.
Aha. So that is -4. So
Okay.
this is the partly finished equation of our new line.
Okay.
But this new line goes through this point, 1 comma 5. So how can I get the complete equation of this line? In other words, this is not an answer you can give. This is just halfway solved. We got to solve for b also.
Mm-hmm.
Let's erase that old line because we got everything out of it we needed, which was the slope.
Mm-hmm.
Now how do we solve for b?
So to solve for b, you have to find the y-intercept.
This is x,
So x and y. So the y-intercept would be 5.
not the y-intercept.
Or just the y value.
B is the y-intercept.
Yeah.
That's what we're solving for. But if this line goes through this point, then that point has to satisfy the equation. Whatever the equation ends up being, that point has to satisfy it.
Yeah.
So that allows me to solve for b by substituting that point for y and x.
Okay.
So what's the next line?
So the next line would be y is equal to...
Yeah? I'm going to substitute this point for x and y.
So y is equal to negative 20 plus 5.
Let's say it one more time. Listen to my words. I'm going to substitute both of those points, x and y, into this equation.
So x would go in
X
the
goes
x.
with the 1. I'm going to substitute 1 in for x, and I'm going to substitute 5 in for y. So the answer isn't y equals. The answer is 5.
5 equals.
Equals minus 4 times 1 plus b.
Okay.
What's b equal to?
So b is equal to negative. So next time would be 5 is equal to negative 4.
Solve that equation for b. What do you have to do to solve that equation for b?
You would have to combine the like terms. So negative 4 times 1, which is negative 4.
Okay, so that's easily done.
Yeah.
Okay, now what?
And then you would add 4 to both sides.
Okay. So what's b equal to?
So b is equal to 1.
What's b equal to?
1.
You're going to add 4.
Oh, add 4, so it'd be 9. So 5 plus 4, so it'd be 9.
Okay. So again, you did the same thing.
Yeah.
You combined the two numbers that were on opposite sides of the equal sign. You can never do that.
No.
Because you just can't do it. They're on opposite sides of the equal sign. The only thing you can do to an equation is add the same number to both sides or subtract the same number from both sides, whatever.
Okay. Yeah.
But you're going to have to, you can look at this two different ways. You can look at it as you're going to add 4 to both sides, which is what you kept saying, but then you kept saying b equals 1.
Yeah.
Or you can look at it the way I look at it, which is I want to move that to the other side of the equation. That means I have to change its sign. That means I have to make it 5 plus 4. Results in the same thing. It's just a slightly faster way of looking at it. But the most important thing is to not make that mistake. So if b is 9, what is the equation of our line?
So our equation would be y is equal to 4x plus 9. Negative 4x.
And that's the answer.
Okay.
For 8.
Okay.
And that's the way you want to do pretty much all of these kind of problems. In other words, the classic 3 problems for algebra is they give you 2 points. What's the equation of that line? They give you a point and slope. What's the equation of that line? Sometimes they give you f of 1 equals 8 and f of 3 equals 4. Well, that's 2 points. Okay? So all of it boils down to coming up with being able to come up with the equation given slope and point. Okay? So this one.
Okay. So for this one.
Okay, here's the equation. Here's the line they have given us. Hold on.
Okay.
And they want the equation of the line that is perpendicular to this line and goes through the point
Okay.
2 comma minus 3. Notice that that 2 minus 3 has nothing to do with this over here.
No.
Completely
No.
independent. That's just a point that our new line goes through.
Okay. So
the equation of the new line, we're going to start out calling it this.
yeah, mx plus y equals mx plus b.
Okay, what can we solve? What do we know from that form?
We know the slope, so -2.
Slope
X.
is perpendicular.
Yeah.
Not parallel, perpendicular.
No. Just perpendicular.
What does perpendicular mean about slope?
Perpendicular
Slope of this
means...
line, the slope of that line is -2.
Yeah.
That's not the slope of our line.
Okay. So...
What's the slope of our line? What's the slope of any line perpendicular to that line?
So this would be -1/2. Or, yeah, -1/2.
Remember, there's 2 steps.
So you
What are the 2
change
steps? What is the slope of the perpendicular? What are the 2 words that describe it?
negative reciprocal.
Okay, so first of all, what's the negative of that?
The -1/2.
Okay, if I wrote -1/2, I have taken the reciprocal, but not the negative reciprocal.
So it would just be 1/2.
Yeah. In other words, you have to apply both steps. You can't apply one of them. You can't just reciprocate it. It's positive 1/2. So now we know that our new line has a slope of 1/2.
Okay.
All right. So we get that far. Now what?
Now you have to find the y.
No.
So it'd be y is equal to 1/2 x plus b. So...
Yeah. And it goes through the point.
To -3.
Okay. So what do I do next?
So now... Oh, man.
What am I missing here? I've solved for the slope. No. Our final answer is going to be y equals some number times x plus some number.
Yeah.
What's the missing thing here? What do I not know about this line?
If it's perpendicular.
No, I know it's perpendicular. They told me.
Yeah, we know it's perpendicular.
What do I not know looking at this equation that I'm pointing at here?
B.
Okay. So how can we solve for b? That's always the next step, is solving for b.
Okay.
Once you get slope, then the only thing missing is b.
Yeah.
How do I solve for b?
Okay, so... Okay, so you would...
This is x.
And y. So you always substitute x and y into the equation.
Okay, so tell me what the next line to write is.
So -3 is equal to 1/2 times 2 minus 3.
No.
Or
plus b.
Yeah, just that. Plus b,
Plus b. I haven't solved for b yet. I don't know what it is. That's the whole point of substituting this one single point that has an x and y value into this equation right here, is so that I can solve for b. Okay, now do the rest of the algebra.
Okay, so 1/2 times 2, so it'd be -3 is equal to 1.
-3 is equal to 1 plus b.
Plus b. And then you would subtract 1, so it'd be -4 is equal to b.
All right. And what's our final equation that we're going to write as an answer?
Y is equal to 1/2 x, where are we? Oh, -4.
Okay. That is a method that you are going to repeat over and over and over.
Okay.
Studying algebra. All right. Let's see. Now let's take a look at this roughly.
Okay.
Hold on a second. All right, let's talk about least squares fit,
Okay.
which isn't where we should be focusing. We need to focus on the previous 10 questions and repeat that. But roughly, if you have a series of points, like they do in this graph,
It's a positive correlation.
well, that looks an awful lot like a straight line. Not quite.
Yeah.
But I could draw a straight line through it pretty easily. Okay? That's what linear regression is.
Okay.
Is if you have a series of data points and you want to try to fit a straight line through those data points, you feed it into your calculator, the series of data points, and it comes up with an equation of that line. It's hard to do manually because did I draw my line correct, or was maybe this a little bit better line to draw through those points? It's hard to tell.
Yeah.
There is a mathematical
kind of
algorithm that the calculator will do automatically. And the calculator comes up with the best fitting line to that series of points.
Okay.
Now, when they say a positive, a negative, or no correlation, it means how close do those points come to a straight line. Pretty close. That'd be a positive correlation there. Whereas if I had a series of points like this,
it'd be like a no correlation.
how do you draw a line through that? In other words, do you draw it like that, or is it like that, or that has a very low correlation, or no correlation.
No correlation.
And a negative correlation, not positive what a negative correlation means. You either
Just like,
well, when you do a linear fit, they come up with an answer, and the answer is they give you M and B, which allows you to come up with the equation of that line. In other words, if they give you an M of 2 and a B of 3, that means the equation of that line is y equal 2x plus 3. And so I'm not sure what they're after.
yeah.
Well, let's answer their questions. What is the roasting? Notice the horizontal axis is the weight of the turkey. Vertical axis is how much time you have to cook it.
Okay.
Now, clearly, the heavier the turkey, the longer you have to cook it. Now I'm getting hungry.
Yeah, me too.
My lunch coming up. I'm talking about turkeys. That's no fair putting this at the end of the session.
Seriously, I'm like starving right now.
I am too. Okay, so you got that right. What is the roasting time for a 12-pound turkey? We go over to 12, up to what it is, 4. Okay? Write an equation that models the roasting time as a function of the weight of the turkey. Interpret the slope and y-intercept of fit. Well, we got 3 minutes. That's about all we need to do here. What is the slope of this line?
So the slope,
Pick 2 easy points.
Okay, so would you draw,
I would pick this point here because I know what its x and y coordinates are. This point here, I got to guess. So pick that point. What is that point?
3, or my bad, 8 and 3.
Okay. Pick another point that's on a easy to read, results in whole numbers.
Let's do 20 and 5.5.
Okay, so 20 and 5.5. What's the slope of those 2 points?
So it'd be y2 minus y1 over x2 minus x1.
Okay.
So,
This is y.
so you do.
This is y2. That's y1.
Yeah, so 5.5 minus 3
Okay.
over 8, so 20 minus 8. So, yeah.
What's that answer?
So 5.5 minus 3. That's 5 point here, just a sec.
It's 5.5. Think about it on
Yeah,
a number.
5.
5.5 minus 3 is going to be what?
5.2.
2.5.
Or 2.5, yeah.
2.5. 2.5
Okay.
divided by 12. What's the slope? What is that slope?
So 2.5 divided by 12.
Excuse you, David.
That'd be...
Hi, Jill.
Hi, I'm sorry to interrupt. If you guys need to go longer, feel free if you have time.
I think this will be fine if we finish right here. We're at the end of this one page.
Okay, whatever works for you guys. I didn't want to cut your time short if you
I'm
need to go
reluctant
longer.
to stretch it over more than an hour.
Okay.
And in fact, I wanted to talk to you a little bit about that.
Okay.
Jill?
Yeah, she's here. Here,
Sorry, what?
just a sec.
I would like you to consider, instead of doing hour appointments with Dylan, let's try half-hour appointments.
Okay.
I think it would make more sense, and I'm not suggesting you change his, 2 hours a week to 2 half hours a week. I'm suggesting whatever amount of time you want to devote, that we'd probably be better off in half-hour time segments.
Does it kind of seem to go too long and
I
then...
think everybody loses their focus when you go too long.
That's fine.
Some
And
people, people it doesn't bother.
Yeah.
But I think Dylan would be better off doing half-hour sessions where he can focus 100% of the time for that half hour.
Okay.
Okay?
That's
Just
great. Sure.
Keep that in mind. It's something relatively new. The only reason I can offer it is because it's online. I wouldn't be able to offer that if it was in person. So it's a relatively new thing, but I'm discovering more than half of my students love it, and they have gone to half-hour sessions. And
well, that's kind of what I thought. Yeah, and Mike had set up the hour session. So I think that 30 would be good because this is it's a lot to absorb in one time.
Definitely is. And I just think that, if he's going to do 2 hours a week, let's do 4 half-hour sessions a week.
That's great.
If he's going to do an hour a week, let's do 2 half-hour sessions a week.
That's great. I agree. I totally agree. Because I know.
Try it.
Yep.
Yeah. Let's try it.
Well, that would be great. Okay.
Dylan isn't more comfortable with it. Most people dread the whole hour, but they don't so much dread a half an hour.
Well, he dreads an hour, and I think
everybody does. Everybody does. Difficult material. It's real hard to focus for a full hour for anybody.
It is. No, it is. I totally agree. So we'll I'll discuss that with Mike, and you would know best since you do this all the time. So I think that's great.
Well, it's going to be different for everybody. We really need to probably ask Dylan after we try it a little bit. And if he prefers it, then that's the way I would suggest we go.
Yeah, I think I know he will, because I think that his brain hurts after about an hour to try to get all these concepts. Do you know what I mean?
I spend so much time with kids in hour sessions where I see them start looking at their clocks and the watch at the 45-minute mark, and they're done. They're fried.
They are fried, and you're absolutely right.
You get more efficiency if you do half-hour sessions.
Well, I'm for that, so I think that's good. And yeah, do you see, are there some areas we need to focus on that he's struggling with a little bit?
I'm finding them, and I think we are focusing on them. And whenever I see an area, I really try to slow down and spend time on that and make sure that he's proficient in that area.
Okay.
And there are definitely some very fundamental areas here that he needs to be proficient at.
Okay, shoot, because he's got a test coming up. Can I relay that, David, to his teacher? Are there certain ones that he really needs to focus on?
It depends. I come upon them as we go through these things, and when I see a weakness, I try to focus on it. It's not something that I think his teacher. It's, I don't know. The job of the teacher and the tutor are really completely different. She's teaching to a class of kids. I'm trying to help Dylan individually.
Right.
And sometimes that means we have to spend a half an hour on whatever.
Just one concept,
yeah,
right.
exactly, one concept. And it'll change from time to time.
Okay.
But
Okay. Well, he's got a test coming up over this material.
well,
So
he's okay on it. If he absorbed
Okay.
what we've studied today, I think he'll be okay.
Okay.
But Dylan, you still there?
He's right by me. He's right next
Okay.
to me. Yeah.
That final answer isn't quite right. We don't want to
Your
give
final
a
answer
slope.
isn't quite right.
How
Let
would
me
I
put-
turn that into a number that I could report as a slope?
How could you turn that into a number that you could report as a slope?
Um,
That isn't quite right.
to turn it into a slope.
Yeah.
Isn't quite
In
right.
other words, I don't want to give a slope as 2.5 divided by 12. I want to give it in whole numbers.
Okay, so you just divide it.
Well, yeah, or multiply top and bottom by 2.
Okay,
Notice
yeah.
you can always multiply any number by the number 1, and that's what 2 over 2 is. And that turns it into 5/24ths, and that is a proper slope.
Okay.
Because it's a whole number integer there and a whole integer there. In other words, you don't want to report your slopes in fractions or decimal.
Okay, cool.
Okay?
Okay.
And I will let you go and meet with you tomorrow.
All right, cool. Sounds good.
All right, Dylan. Bye-bye.
All right, thank you. Bye.